Most black holes in the universe are hiding. So how do we find these big, hungry, cosmic beasts? Here's a clue: a space telescope with X-ray vision. Black holes are one of the biggest mysteries of the cosmos. With gravity so intense, nothing can escape, not even light. The smallest black holes we know of form when big stars run out of fuel and collapse. Then there are the supermassive black holes. Scientists don't currently know where they come from, but we do know they have up to tens of billions of times the mass of the Sun. Scientists think every large galaxy in the universe has a supermassive black hole at its center. But what role do they play in how galaxies grow and change? There are several ways to look for supermassive black holes. We can observe the way stars orbit around them. This is how scientists identified the supermassive black hole at the center of our own galaxy, the Milky Way. We can spot the powerful jets of hot plasma that are ejected as they feed. We can detect the ripples in space-time that occur as they merge. Or we can even detect the radiation emitted when stars travel too close and get torn apart. We can also spot the glowing disks of gas and dust that orbit black holes, which can sometimes resemble the approximate shape of a donut. If the donut is face on, we can see the bright disk at the center. But there's a problem. Most are only showing us their edge, and the bright disk is obscured by the wall of this donut. That's where NuSTAR comes in. The Space Telescope has powerful X-ray vision that can see certain objects or features of the universe that are invisible to the human eye. The high-energy X-rays can also penetrate thick gas and dust. Recently, we combined 10 years of NuSTAR data with measurements from other missions to sample the sky at X-ray wavelengths. We now measure that at least 35% of the growing supermassive black holes in the universe are hidden. It's important that we find and study supermassive black holes because they can teach us a lot about how galaxies grow and evolve. For example, black holes slow down star formation. If we didn't have a supermassive black hole in our own Milky Way, we would expect to have many more stars in the sky.